There was one, and I
That's
said to
evil.
look ahead on your formula sheet. Yeah, I was being extra evil. Of course. That's always my plan. On the top of page 54, you have the last formulas for this unit that are on your formula sheet. So basically the whole first column on your formula sheet is identities, formulas. And these are called the double angle identities. For the double angle identities, for those of you going on to AP Calculus, these ones for sure. Memorize the sine and the cosine ones. Tangent, not as important, doesn't come up as much, but the sine one and the cosine one come up a ton. We're actually going to prove one of them, just for fun. Because anything that's on your formula sheet has to be provable, so just for fun, we're going to prove this. And it's really tricky to prove because it's already your main strategy, change things to sine and cos. Already done. Get a single fraction on both sides. Already done. The trick to this proof uses math that you already knew. Some of you were probably advanced, you had already known this in kindergarten. So the trick to this proof is going back in your brain and using something that you knew in kindergarten. By grade 1, you were an expert at it already. What is some of the very first math you learned?
Addition, subtraction.
Addition, subtraction. What would be a good example of something that you would go to a kindergarten kid, if you asked them addition, do you think they'd get 357 plus 841? No, probably not. What do you think you would check on them?
So what's 3 apples plus 5 apples? How many apples does Johnny have?
That might be even pretty hard for a kindergartner. If I did 3 plus 5 for some kindergarten kids, I think that would be hard for them. But if I wanted to check an addition thing that I think they would get, I'd probably check 1 plus 1. And 1 plus 1 is 2. And 1 plus 1 is 2 is this strategy that we have to use in this proof. I have 2 thetas here. That's the same as 1 theta plus 1 theta. And if I have 1 theta plus 1 theta, then this could be my alpha and this could be my beta, and I could use my alpha plus beta formulas from yesterday. That they wouldn't know in kindergarten. They would get the 1 plus 1. And then you'd be like, okay, what are your sum and difference formulas for sine and cosine? And they'd be like, what? But if that's my alpha and that's my beta, this is equal to sine alpha cos beta plus cos alpha sine beta, right? Alpha, beta. It just happens that our alpha and beta are exactly the same thing. Can you see that the sine cos and the cosine are actually like terms? And you can use your kindergarten math one more time. If you have one of these and add another one of those, you will have how many? Don't scream it all out at the same time. You will have 2 of them. And our proof is done. So just like our other identities questions, you're going to get questions where you have to take one side and switch it from the left side to the right side, sometimes right side to the left side, to be able to solve problems. So we're going to just, first of all, get good at working with, maybe, there we go. Wow. Struggling right now. Here we go. Example 1. Given angle theta is in standard position with its terminal arm in quadrant 4 and cos theta equals 2/5. Oh my goodness. Have we not heard this for 2 chapters in a row? Isn't the beginning of this question like the beginning of so many questions we've had so far? Like even before they get to the question, your brain should go, I should draw a triangle in the right quadrant and make my reference angle and label the sides and see what I have. That's definitely what's going to happen again. Like up till the comma, it's in standard position quadrant 4. So I draw an angle in quadrant 4. I would go back to my nearest x-axis so that I could label my reference angle. And I know cos is 2/5. That means this side is 2 and this side is 5. Could I do a squared plus b squared equals c squared? Absolutely. This side is the square root of 21. We've done so many questions that this starts off with. Yesterday we did double triangle questions where we had to do 2 of those for alpha and for beta. So a lot of questions start this way. And now in part A it says, what's sine of 2 theta? The problem is our picture includes theta. Our picture does not include 2 theta. But we have a formula for sine 2 theta that says it's equal to 2 sine theta cos theta. And now on the right hand side I have only theta. What is sine of theta? Well, if I look at this picture, can you see that sine of theta is negative root 21 over 5? Because it's in quadrant 4, it's negative. And it's the opposite over hypotenuse. And when I do my substitution, just like we were careful yesterday, will I replace just the theta or will I replace all of sine theta? I will replace all of the sine theta with negative root 21 over 5. I'll replace all of the cos theta with 2 over 5. How do I multiply fractions? Multiply the tops, multiply the bottoms. Oops. 2 times 2. Negative 4 root 21 over 25. Part B is a cos 2 theta. And once again, I don't have in my picture a cos 2 theta. So I should go to my formula sheet and switch to one of my formulas. But the interesting thing about cos 2 theta, and I have them up over here as well, they have alphas instead of thetas. Do you see that for cos 2 alpha, there are 3 formulas? With those 3 formulas, all 3 are true, and you can use any one of the 3, but usually there's one that's slightly better than the others. So in this question, okay, you could either try to decide which one's slightly better and go with that, or you could be like, I don't want to decide, I'm just going to randomly pick one and see where it goes. Both will work out perfectly for you, okay? As far as which one is slightly better in this situation, pick one, look at all 3, see if you can decide which one's the slightly better one. And did you pick this one? The reason this one is slightly better, do you see in the question they told you what cos was? They told you it was 2/5. We had to figure out sine. Is there a chance with sine you could have screwed up in doing a squared plus b squared equals c squared? Possibly. Could you have forgotten the negative? Possibly. So there's little tiny mistakes you might have made along the way in figuring out sine. So that's why using the cos is slightly better. If you didn't make any mistakes in figuring out sine, the other formulas are equally as good. But now, I have a 2. Cos is 2/5. So cos squared will be 2/5 squared minus 1. Again, I need to write my final answer as a fraction. I'll do my order of operations. Squaring this will be 4/25 minus, I'm already predicting I'm going to need a common denominator. This is 2/1. So 8/25 minus 25/25 gives me negative 17/25. How can I use the answers from A and B to tell what quadrant 2 theta is in? Does anybody know what quadrant theta was? Theta was in quadrant 4. If you doubled it, what quadrant is it going to be in? How can you use the answers from A and B to see where 2 theta is in? Got an idea?
If they're negative, then they're in a certain quadrant.
They're going to be in the 3rd quadrant because both sine 2 theta is negative and cos 2 theta is negative. According to your cast rule, that has to be quadrant 3. All right, questions to circle on this one. Just number 9.